In the last tutorial I introduced the UV coordinates, but there was some misunderstanding with my explanation because I used the coordinates which I am familiar with on 3GS, the book of shaders, and shader toy, for example. GODOT coordinates are inverted in the y-axis. I just make the clarification so you don't get the wrong idea about coordinates. Drawing shapes. How do we draw shapes within shaders? Keep in mind that the code you write into shaders is being processed in parallel for each vertex or fragment, so we can think sequentially as we code on the CPU. Each fragment must know how to draw itself depending on certain conditions. Hence, the method used for drawing shapes on shaders is by using distance fields. A distance field is a visual representation of distance between coordinates. This definition might change because distance fields are used for many things, like drawing text, drawing 3D shapes. In fact, the most advanced shaders that you can find on Shader Toy website were made using distance field. Here we will focus on 2D drawing for now. Usually to draw shapes we use distance fields more shape functions like steep and smooth steep. This way we get a shape which we can control its size using the edge parameter of these functions. So let's create a mesh instance. We create a plane inside, a material, and a shader of type spatial, render mode unshaded. And inside the fragment function, we define the center of the shape, assign the distance function to the variable distance field, and assign the distance field to albedo. In this way, we have drawn a distance field that will help us to draw a circle. Now we create a circle using the step function. We can change the size with the edge parameter of the function. Let's declare a uniform variable to control the size from the shader parameters in the range from 0 to 0.5. Let's assign the variable to the step function, and now we can control the size of the circle. To draw a rectangle, we will remap the UV coordinates. This is a very common technique to obtain coordinates similar to the Cartesian plane with positive and negative axes. In the upper left corner we have negative numbers, which cannot be represented in the RGB color space because it can only represent colors in the range of 0 to 1 positive. So we can say that the lower right part is a safe area, since it's the only one that represents positive numbers from the original UV map. As you can see, on the left side are the negative coordinates on the x-axis, and on the top side are the negative coordinates on the y-axis. Next, we will reflect the UV coordinates to obtain a distance field that will allow us to draw a rectangle. We achieve this by using the abs function, which transforms the negative coordinates to their positive values. Now, we're going to duplicate this plane, and then we're going to declare unique both the material and the shader. Now we will modify the uniform variable to range from 0 to 1. Clear the code for creating the circle, and let's declare a new variable to store the new Cartesian plane-like coordinates and assign them to albedo to display their appearance. We declare a new variable vec2 to store the mirrored UVs and assign them to albedo again to display their appearance. Now we assign the x-axis to the df variable and display it in albedo. As you can see, we got reflection in both axes. Let's use the darken and lighten mixing modes that we have discussed in the past. using the min and max functions in particular. Now pass as parameter the two reflected axes of the UV map to the max function. This way we obtain a distance field to draw a perfect square. Similarly, we can control the size with the uniform variable. But remember, we were drawing a rectangle, not a perfect square. To achieve this, we have to separate the x and y axis and apply the step function separately before blending them with the max function. Let's use two uniform variables to control width and height of the rectangle. Now we have a rectangle which we can control its width and height.